Good evening, students. Today, it is the continuation of our that on discussions on force, laws of motion. Okay, so basically, today we are going to discuss about the that one that connected motions. Okay, that concept we are going to discuss. As you know, my name is Amarnath. So basically, we are going to discuss problems of connected motion. Okay. Yesterday also we have discussed actually a little bit, and today one more thing we are going to discuss actually apparent weight. Okay, reading of spring balance, reading of weighing machine. Okay. So basically, you see what we are going to discuss today. Theory part is already actually discussed, but we have to do some numericals on this. Say this is a lift. Okay. Say this is a lift. Well, which is accelerating upward, okay? Which is accelerating upward. Say acceleration is 5 meter per second square, okay? With this acceleration, it is going up. Well, and we have an object inside the lift, okay? So say this is of say 2 kg. Well, now my question is that in that situation, find the normal force by the floor on the 2 kg block. Okay, that is my question. Okay, this is basically on F equal to ma only. Okay, nothing else. So try to understand. See, first of all, actually we should draw the free body diagram of the object. Okay, so FBD, free body diagram of the object. Say this is 2 kg. Okay, this is 2 kg. Now you see 2 kg is experiencing one gravitational force, okay, that is gravitational force, which is equal to mg. It means that is nothing but 2 into z. Z value is always we take 10 only. So it means weight equal to 20 Newton, okay. And second thing, the surface is giving it up a normal force, okay. So that's the value we are going to calculate actually. We are going to calculate the normal force only, the force given by the floor. But remember, up till now, whatever problem we have discussed, always we keep on writing n equal to mg. N equal to mg. Okay? W is nothing but mg only. But here you cannot put. Because you see, this time the lift is accelerating up. It means that 2 kg also has some acceleration. Na? So what you need to do, you have to write the force equation in the vertical direction. Say vertical direction is that one, okay? Y-axis. Say. So what you have to write? Sum of all the forces along y direction must be equal to mass and acceleration along y. Okay. So what are the forces? First force is N. Then mg is downward force. Okay. mg is downward force. Weight is the downward force. Must be equal to mass into acceleration. Okay. So this is the equation. Remember, normally my suggestion, if you take acceleration upward, it means upward direction is taken to be positive. Okay, here I have taken n as positive, and opposite to acceleration, my suggestion, opposite to acceleration you take negative. Okay, because force is a vector quantity. No? So now you see n minus mg value is already you know that it is 20, and mass is 2 kg, but 2 kg's acceleration is 5 only. Because lift is accelerating up, it means all the objects inside the lift also accelerating up only. Na? So it means from this we can write n is equal 20 plus 10. Okay. So normal reaction will be equal to what? It is nothing but 30 Newton. Okay. So that is the answer. Well, now one interesting point is that you see, now one interesting point is that if the lift was not accelerating, so obviously say this is the normal table. So that is 2 kg. So here actually downward force is 20 and upward force is normal reaction, and here actually normal reaction is 20. But now you see, now normal reaction is 30. It means when it accelerates up, normal reaction increases. And remember, if you even you can also feel like this, huh? When you remain in the lift and starts the lift, okay, if the lift starts moving up, so at that moment you feel little bit heavy, okay, because acceleration is upward, so you give a force on the floor. No, that is nothing but a normal force, okay, a little bit more than your weight, okay, so that is called that one normal. Yeah, you can say this is also apparent weight, okay. Normal weight is 20 only, but apparent weight now become 30 Newton, okay. Now you see, interesting is that, say in this situation only, in this situation, say this is 2 kg block. And here I have put a weighing machine, okay? Here I have put a weighing machine. This is weighing machine, okay? WM. Say this is weighing machine. So if I ask you, what is the reading of weighing machine? So reading of weighing machine is nothing but the normal reaction. From today, you must be clear about that, okay? Reading of weighing machine is nothing but the normal reaction of the floor on which the weighing machine is kept. So here weighing machine is kept, na? So it means we are asking about a normal reaction. If you place a weighing machine here at this place, you place a weighing machine, then obviously the reading of normal reaction will be, yeah, reading of the weighing machine will be 30 Newton. And it is also called apparent weight. Okay. So you please write down reading of a weighing machine, okay, is the, as a weighing machine reading, it is also called apparent weight, okay. Bracket, in bracket you can write apparent weight. Is the value of normal reaction only. Is the value of normal reaction by the floor only, okay. So remember, if the lift is accelerating down, okay, then the equation will be, you see, if the lift is accelerating down, say same question, say lift is accelerating down, okay, a equal to say 5 meter per second square, say I'm taking same only, okay. So if I draw the free body diagram, so it will be mg, this will be n, but this time you don't write n minus mg. This time you write mg minus n equal to mass into acceleration, okay? Mass index. Why? Why? Because acceleration is downward. So I have taken downward force as positive. So upward force will be negative, okay? So from that you can calculate the value of n, and which will be obviously, it will be less than that, even 20 also, okay? Now it is greater than 20, but in this case, it will be less than 20, okay? So this is not, if you don't want, you don't copy it, this part, or you can copy it, no issue. But remember, I'll give you some numerical on this, okay? So please copy all these things and get ready for that one, a question for you, okay? Do you have any doubt? Anybody having doubt?
No, sir.
Okay, okay. Just copy it. Find the reading of the weighing machine WM in the three following cases. Okay. So case number 1. So this is a table. And here is the weighing machine. Okay. And this is the object. 5 kg. Remember, weighing machine has no mass. Ideally, weighing machine has no mass. And this is acceleration. I am taking acceleration 2 meters per second square. Okay, this is the first case. You just, the table is accelerating up. Okay, table maybe, you see, I can also just by my hand also I can that one give an upward acceleration also. So this is the weighing machine. Weighing machine is simply a plate like this. Okay. So this is the object. So this is 10 kg. Okay. But this time it is accelerating down. Okay. So 2 meters per second squared. Okay. So in this case, what is that one? The reading of weighing machine. And the third case is so this is the weighing machine. And this is the object. Say this is 4 kg. Okay. But it has no acceleration. Okay. It has no any acceleration. Nothing is given means acceleration is 0. Okay. It is stationary only now. And this is fourth question. Say all the find the reading of the weighing machine, all the 4 cases you take. Okay. So this is the weighing machine. This is the 5 kg block. An object is moving up with velocity 2 meters per second. Remember, it is not acceleration. It is velocity, which is constant. So in this case, what will be the that one reading of the weighing machine? Okay, all the 4 cases. So you please give a try. Okay. Let me try the first one. If I draw the free body diagram, 5 kg, 5 kg. So downward force will be 50. mg.
Yes, sir.
I'm taking always 10, okay? Upward force will be the normal action, and I am going to calculate the normal action only. But equation will be upward force minus downward force equal to mass into upward acceleration, okay? So from that I can get n equal to 50 plus 10. It means n equal to 60 Newton. And this is nothing but apparent weight. And this is nothing but ring of weighing machine, okay? This is the answer only. In the second question, this is 10 kg. So draw the view diagram. Downward force will be 100 mg. Upward force is normal action. But remember, this time acceleration is downward. So downward direction should be taken as positive. It means 100, which is plus 100, minus normal action equal to mass into acceleration.
Okay.
That we can calculate 100 minus 20 equal to n. So n equal to 80. So 80 Newton is the apparent weight, or 80 Newton is the normal reaction, or 80
Normal
Newton is
reaction.
the reading of weighing machine. All are same only, okay? All are same. Apparent weight, reading of weighing machine, and the normal reaction. You wanted to say something?
No, sir.
Okay. So similarly, actually, the third one will be very simple because there is no acceleration. So upward force is normal reaction, downward reaction is 40. So anyone can be taken as positive, nothing else. So n minus 40 equal to mass into acceleration. But acceleration is 0, no? So it means n equal to 40 Newton. So apparent weight is nothing but actual weight only here, okay? In this case, actually, apparent weight and the actual weight both are same, okay? So from that, what you feel, when you accelerate up in a lift, your apparent weight increases or decreases? Tell me. When you accelerate up in a lift, your apparent weight increases or decreases?
Sir, it increases.
Increases. You see, 5 kg block becoming 60 Newton, na? 5 kg weight,
Yes.
okay, becoming say 6 kg weight now in the first case. And when you accelerate down, remember, velocity down, accelerate down, that is different, okay? When you accelerate down, then in some cases, na, in the lift, you feel like weightlessness, na? As if your weight goes on decreasing, okay? When it happens, when the acceleration is downward, okay? So it means when acceleration is downward, your apparent weight reduces. See, this is 80 Newton. Actual is 100 Newton, 100. 10 kg means 100 Newton. But apparently it becomes 80 Newton only, okay? And when you get actual weight, it is not when the acceleration is 0, okay? So this is the third question. Fourth question is just given to confuse you, nothing else. Because in fourth question, you can see, in the fourth question, you can see this is 5 kg block, draw the Fibonacci diagram. There it is 50, there it is normal reaction, okay? But we know that normal reaction minus 50 equal to mass into acceleration. But here also acceleration is 0 because velocity is constant, you know. As the particle is going with constant velocity, so obviously acceleration will be 0 only. So it is nothing but n equal to 50, which is nothing but actual weight only. Apparent weight is nothing but actual weight only. Are you getting it 100%?
Yes, sir.
Okay. Remember, I am going to give you quiz, okay? On the basis of these questions only. It will be a Google quiz only, and you have to try to attempt 100%, okay, there.
Okay, sir.
Good. Let us change the flavor. Say this is one ceiling, okay? You can say that ceiling of the lift only, okay? Say this is a thread and this is a 2 kg block, okay? But the lift is accelerating up, okay? So lift is accelerating up by 5 meter per second square, okay? Now my question is, find the tension on the thread. Tension on the thread. Okay? So it is also very simple. What you do? Fibonacci diagram. This is 2 kg. So as it is 2 kg, Fibonacci diagram is always drawn for the object, huh? Not for others. Or you can draw for a point also, no issue. So it is 2 kg. So it means it is 20 Newton. Okay, this is the gravity. But upward, the thread is pulling it. Now, tension is always a pulling force. And Karthikeyan, remember, this part already discussed. Okay, so I'll provide you the
Okay,
visual experience. Okay, so you go through it.
Okay, sir.
What is tension? What is normal reaction? Okay, and I hope you will understand. Okay, before the coming class, you please complete watching the videos. Okay. So
Okay.
actually the thread is pulling the object upward. Now that is called tension. Tension is the force on a tight string, stressed string. So now you see, again, you have to draw the equation, force equation up. You know that, say, vertical direction is y. So sum of all the forces must be equal to mass into acceleration in the y direction. So Fy upward. So, upward force is tension minus downward force must be equal to mass into acceleration. So it means tension equal to 20 plus 10. So tension equal to 20 plus 10 is nothing but 30 Newton. So this time tension on the thread is 30 Newton. But if the lift was stationary, if the support from the ceiling, from where the object is suspended, if it is stationary, then of course tension will be only 20. But as it is accelerated, so the tension becomes more, 30 Newton. Okay. If you increase the acceleration, the tension will be again will increase. Okay. And it sometimes it may break also if it cannot tolerate this much tension. Okay. So that's called breaking stress, at which the thread breaks. Okay. And remember, if I put a spring balance here, I hope you have seen the spring balance only. Then you may be asked to calculate the reading of the spring balance. And the reading of the spring balance is nothing but reading of the spring balance is nothing but tension only, nothing else. Okay. Reading of weighing machine was normal reaction. So here, the reading of spring balance. But spring balance always reads the tension only. Reading of spring balance is equal to tension on the thread where the spring balance is connected. Okay. Where the spring balance is connected or placed. Say if I ask you, say this is an object, say this is 5 kg. So what is the tension? It is 50 only now if it is stationary. But I am asking if it is accelerating down, okay, say 2 meter per second square. Then I am asking the reading of spring balance, okay? You just calculate tension only, nothing else. Calculate the reading of spring balance. So what you do, you always draw the free body diagram of object only. Okay, this is 5. So this is 50 because gravity. And this is tension. Tension. Don't put normal action. Tension. But now you know that it is accelerating downward. So which force will be positive? 50 will be positive. Tension will be negative. Equal to mass into acceleration. Acceleration value is 2. So it means 50 minus 10 equal to T. So T equal to 40 Newton. And this is nothing but the reading of spring balance at this moment, okay? And this is also nothing but the apparent weight only, okay? Because spring balance or the weighing machine, okay, all will give you the apparent weight only. So you please copy all these things and get ready for that one. A numerical I'll give you, okay? Okay, now you please try all these 3 questions. Find the reading of spring balance in the following situations. In the first situations, 2 kg block suspended when the ceiling is accelerating up with 2 meter per second square. In the second case, 5 kg block suspended from the ceiling and which is from that one accelerating downward, okay, which 5 meter per second square. And third one is a little bit interesting one. That is 3 kg block is suspended from the ceiling by means of a thread and which is accelerating down with 10 meter per second square. Okay, it is called actually free fall situation. Okay, because gravitational acceleration is also 10 meter per second square and the lift is also accelerating 10 meter per second square. It means what? So lift is that one that lift is falling freely, like this. Accident happens, okay? Lift falls down freely, like that. Okay. Anyway, but mathematically, let us see what will happen. Okay. So first you give a hit on it. Okay. So in the first question, this is 2 kg. Downward force will be 20. Upward force will be the tension. So acceleration is upward. So it means I'll take the upward force as positive. So plus T minus downward force equal to mass into acceleration. It means T equal to, I hope this part you understand, 20 plus 4. It means tension equal to 24 Newton. So it means the reading of the spring balance is 24 Newton. Respond me whether you understood or not. Any doubt?
Yes, sir. Understood.
Okay. Nice. In the second case, again draw the free body diagram. 5 kg, downward force is 50. Tension will be always pulling force. Tension is always pulling force. But this time acceleration is downward, no? So it means downward force should be taken as positive, okay? So 50 minus tension equal to 5 into acceleration, okay? Mass is 5 kg, okay? Mass into acceleration. Net force equal to net force along y direction equal to mass into acceleration. We are repeatedly using this only, okay? So 50 minus 25 equal to T. So it means T equal to 25 Newton. So this will be the reading of that one, okay? And spring balance only. And here in this case, here actually the case is little interesting, I have told you. Here you see, say this is T, okay? So downward force is 30, upward force is tension. I don't know what is the value of tension. I'll calculate. Acceleration is downward, so I have to take the downward force as positive minus upward force as negative. This is minus means direction minus equal to mass into acceleration. Okay. So from that you can see 30 minus 30 equal to T. So T equal to be 0. Remember. So always apparent weight will become 0. If an object falling freely, the apparent weight becomes always 0. Always 0. It means the reading of the is totally 0. Okay. Say this is a ceiling. Okay. I have suspended just 10 kg block. Okay. 10 kg block. Say it is stationary. So the reading of the spring balance will be 100 Newton. But if I release it, the system will fall down with acceleration due to gravity, 10 meter per second square. So as the system falls down, in that duration, the spring balance reading will become 0. It will be means weightlessness. Okay. It will be like weightlessness. Okay. Same thing will happen in case of that weighing machine also. Okay. If the lift falls down with that 10 meter per second square, the normal reaction will become 0. Means one surface will not push the other surface. If both will be falling down with acceleration due to gravity, 10 meter per second square only. Okay. That is called a free fall. Okay. Free falling object like this. Let us change the flavor of the question now. Okay. Say this is one table. Okay. This is a pulley. Pulley means that wheel only. Okay. This is also a pulley. Okay. And say this is a thread. Okay. Same thread. Say this is 10 kg block. 10 kg. Okay. And this is say 2 kg block. Okay. And here is just a spring balance. And I am asking you, find the reading of spring balance. Okay. Find the reading of spring balance. Remember, same situation is like this also. Say this is a pulley from the ceiling. Okay. This is thread. Same thread is passing over this. And this is say 5 kg block. Okay. And this is say 10 kg block. Okay. And say one spring balance is there. Okay. Find the reading of spring balance. Okay. In both the cases. Okay. In both the cases. It will be little bit lengthy. It will be little bit lengthy, but remember, it is interesting. Okay. Again, I am saying, if spring balance is confusing you, just remove it. You need to calculate find the tension on the thread. Okay. And remember, one more thing. In a single thread, actually, if the tension here is 10 Newton, here also it will be 10 Newton, here also 10 Newton, here also 10 Newton, here also 10 Newton. Because normally, we take all threads, all strings are massless, actually. Our assumption is that threads are massless. So every point tension will be remaining same. Okay. So that point you please write also. Okay. That point you please write down. Strings are taken to be massless, because you see we have not calculated the mass of the string anywhere. We are calculating the mass of the blocks only. Okay. So strings are taken to be massless. Okay. Strings are taken to be massless. And hence, you should learn it, this thing. And hence, at all the points, the value of tension remains same. Okay. So that point actually you should please write it. Okay. And keep it in a box. I can ask you. Okay. In separately. Okay. So let me do it. Okay. As time is also a little bit running out. So let me do it. You see, this is a 10 kg block, so it will little bit heavy. This is 2 kg block, so it will lighter. Okay. So obviously in this situation, 10 kg will fall down, 2 kg will move up. Okay. It is clear. Okay. If it is 10 kg, no one will fall down. Okay. They will stable. They will be in equilibrium. But here 10 kg will fall down. Say 10 kg falling down with acceleration A. So 2 kg will move up with acceleration A. Okay. That is sure. So if you draw the free body diagram of 10 kg, here it will be 100 Newton. And the thread will pull it up with tension T. Okay? 100 Newton T. 100 Newton T. 100 Newton is bigger. Minus tension equal to mass into acceleration. So this is equation number 1. Because acceleration is downward, so I have taken downward force as positive, upward force as negative. So this is the equation for 10 kg. So what I have written? I have written for 10 kg. Okay. I have written for 10 kg. So similarly, for 2 kg, if I write, you see, 2 kg. See, this is 2 kg. So 20 is downward. Tension is upward, because you see same thread. This is the same thread. Okay. Massless. So therefore tension here, if it is T, here also it will be T only, not T1, not T2. Okay. We do not require to take T1, T2. But you see here the acceleration is upward. Okay. So it means this tension will be positive, 20 will be negative. So tension minus 20 equal to mass into acceleration. This is equation number 2. Okay. So if you add both the equation, you can see T will get cancelled. So it will be 100 minus T plus T minus 20 equal to 10A plus 2A. Okay, what I'm doing? I'm just adding 1 and 2. So T will get cancelled. So 100 minus 20 is what? 100 minus 20 is 80. 10 plus 2A is what? It is 12A. So it means acceleration equal to 80 by 12. So if we divide it by 4, so it will become 3, it will become 20. Okay. So acceleration is 20 by 3. And SI unit of acceleration is 20 meter per second square. Okay. But we are asked to calculate the reading of spring balance. It means we need to calculate the tension only. So you put any one equation, okay, the value of acceleration. So equation say I am taking 1 only, okay. From equation 1, 100 minus tension equal to mass into acceleration. Acceleration value already I have calculated, 20 by 3, okay. So what I get, 100, if I bring this part leftward, 200 by 3 equal to tension. You see tension I have shifted towards right, and that 200 by 3 part I have taken to the left. So if you take the LCM, see this part you have to do, huh? If we take the LCM, it will be 300 minus 200 equal to tension, okay? So from that you can calculate tension is to be 300 minus 200 is what? 100 by 3. So this is the answer actually. This is the reading of, it will be like the 33.33 like that, okay? So this will be the reading of spring balance in the first case, okay? Remember, this is little bit longer, okay? Exactly that way, you try this part at home, okay? The second part, this will be a homework only, okay? Second part will be a homework only, okay? So, on that note, actually, I want to wind up today's class, okay? So you please copy all these things, and the time is running out because I have another batch also now. So I'll wind up today, okay? And see all the questions. You have already copied now. You have already copied. So see all the questions and try to solve this once more, okay? Your way, okay? Without copying,
Okay.
without seeing. Yeah. And then in the quiz, whenever I give you, so you'll do good, okay? So Karthikeyan, are you comfortable with the discussions?
Yes, sir.
Okay, beta. Okay, okay. So have you copied all these things?
Yes, sir.
Okay, can I wind up?
Yes, sir. Sure.
Okay, bye bye. Good night. Good night, guys.